Okay, so that's all set, I think. All right, so 3.1. Oh, today, oh, this whole chapter is about parallel lines and planes. Oh, yes. Okay. You know what? I need this notebook. All righty, everybody. So. Oh, yes. Oh, this is such a good section. All right, so what am I going to call this one, though? I have just definitions on here, but that's not a good section name. I'm going to call it angle relationship pairs. Let's turn this light on. I don't know if that helps. Angle relationship pairs. Okay, we're going to start off by officially defining parallel lines and planes. So we'll start off with lines. Now, your definition of two lines that never intersect, you have to kind of get rid of that. It's not that it, well, you got to add to it because it's not necessarily true. We have a counterexample to that statement. I don't know if you remember it. Yeah, so parallel lines, that's true. Those are the ones that kind of look, I'll put it down on here. So these two lines would be parallel. They don't intersect, that's true. But neither do these. If I take one of these and I stick it upright, now it might be kind of hard to see on the, you can just look on the table if that helps. These two lines are still never going to intersect each other, but they're not parallel anymore. Carson?
So wouldn't the definition of parallel lines be two lines on the same plane that never intersect?
Exactly. We have to add the word coplanar to our definition. You can't just say two lines that never intersect anymore because we have these. Anybody remember the name for these? I did tell you once upon a time. Nope. S. It's a short little word. Okay. Skew, yeah, skew lines. So parallel lines, our definition is now going to be coplanar. Keyword, coplanar lines that never intersect. I'm going to put a big star here because parallel, just like 90-degree angles. Remember how I made a big deal? You can't just go around assuming a 90-degree angle is a 90-degree angle without proof. It either has to have the box or they have to tell you in words that things are perpendicular. Same thing with parallel lines. Just because two lines look parallel doesn't mean that they are. So you can't go around assuming that lines are parallel. You would have to either be told or be able to prove that they are. Okay, so you cannot assume lines are parallel. Well, we have a symbol for parallel though, because who wants to write that word 10,000 times? It looks like a long 11. So that's literally our symbol for parallel. cannot assume lines are, yes, I go so fast. Must be given or able to prove. There's a couple of ways that I could tell you that lines are parallel. I could literally come out and say, so let me draw you a diagram. Let's say I had something like this and I had lines L, M, and I had N down here. If I wanted to show you that lines L and M were parallel to each other, I could, somewhere off to the side or in the directions, I could say L is parallel to M, like that. So there would be me writing it symbolically, or we can mark it right on the diagram too. And so if I want to mark it on the diagram, what we're going to do is we're going to put little arrows, or sometimes people fill them in and they look more like triangles, on each of the lines. So if I do something like that, that marking indicates that those two lines are parallel to each other. Now, what if I drew in a fourth line? And I'll call that line P. If I wanted to indicate that lines N and P were parallel to each other, they are obviously not parallel with L and N. So I don't want to use the same marking, because then I'd be saying that all four lines are parallel to each other. So what we do is we would just put two arrows on those. So that's our way to differentiate. Just like with angles, you use one arc or two arcs. Same thing here, we're just going to use number of arrows. Okay, so that's pretty much it for parallel lines. Now we're going to talk briefly about parallel planes. And we have a theorem that goes with that. Parallel planes, you just get to say that they're just planes that don't intersect, because there's no such thing as skew planes. We can't have that. So they are just simply planes that don't intersect. All right, so now we have a theorem that goes with this. I want to see if you can sort of figure out what happens here. So the theorem states, if two parallel planes are intersected by a third plane, then their lines of intersection dot, dot. I want to know if you can finish that sentence. So let me give you a minute to write it down, and we'll sort of think about it and walk our way through it. All right, so imagine this. You have two planes that are parallel to each other, right? So what does that look like? That can literally just be, here's a plane, right? Planes that are parallel to each other. Okay, got it. Now imagine that there's a plane, maybe a vertical plane, that comes through and hits both of these planes. Now, when two planes meet, their intersection is a line, isn't it? If you have two planes and they intersect each other, like the ceiling and the wall, they intersect at a line. So I want you to imagine that you have a pair of parallel planes, and you're going to slice through it with a third plane. There's going to be a line of intersection in each of those where each of the parallel planes meets that vertical plane. What do you think is true about the lines of intersection? Aiden?
Well, I kind of thought too. They can be coplanar or they are parallel.
You're correct on both. Yes, they would be coplanar because they'd both be contained in that vertical plane, wouldn't they? Yeah, so, but they are also parallel, right? So I'm gonna try and draw it, but I'll probably not do a good job at it, but I'm gonna try it. You don't have to draw it, but here's my best version. So there's a plane, and then here's a parallel plane to that one. So now I'm gonna try and come through here. I'm gonna slice through. I'll keep it one that slices through. So now you've got these intersections right there. Oh, I should do it in a different color. Here's where those two meet. Where those two meet. Oh, that's not a bad drawing. Okay, that's all right. So these two red lines, right, because they go on forever, they are certainly in the same plane. That vertical plane contains them, but they are going to be parallel. Yes, so let's finish that dot, dot, dot. If two parallel planes are intersected by a third plane, then their lines of intersection are parallel. Okay, I do want to officially put down a definition for skew lines too. I'm gonna sneak it right in here. So skew lines, these are non-coplanar lines that don't intersect. And if you want to draw skew lines, the best way you can do it is to sort of draw yourself a box and then just pick pieces in the box that are. So there's a box. And so, for example, a pair of skew lines might be this edge and this edge, right? Because if you imagine those just going on forever, they will never meet each other, but they are also not on the same plane. They're not both contained in on the front of the box or the top of the box or the bottom. They don't share a plane between them. And they will never intersect each other. And they are definitely not parallel. So there are skew lines. Okay, so far so good. Everybody's all right? Because now things are going to get real interesting. I got flip. Whoop. Okay. Next vocab word. It's going to be a word that you're going to hear a lot in this chapter. It is the word transversal. And all a transversal is a line that crosses over two or more other lines. And I am going to give you a lot of examples where I start talking about angles like it's a bus map. And I promise it'll make more sense, but I'm going to add it right here. This would be the bus that you'd take from one angle to another. Mrs. Xavier, you are nuts. What are you even talking about? Let me show you. I want you to imagine. I had a couple lines here. Maybe I have a line here. And I want you to pretend that this is the bus map. These are all the routes that the bus is going to go. And here are some locations. Location 1, 2, 3, 4, 5, 6, 7, and 8. So if you're going to draw this diagram, do me a favor, make sure that you number it the same way that I did, because we're going to talk about these angles. So if you have it numbered differently than I do, it's kind of going to make it messy and it wouldn't make any sense. So just make sure you number it in the same manner that I did. I'm going to label these lines. I'll call that line J. You can be line K. And this will be line, what do I have it as? T. So in this picture, we have 3 lines. Who would you call the transversal, which is the one line that's crossing over the others? Well, T, right? Line T would be my transversal. Oh, how funny. T for transversal. There we go. So you'll see whenever this happens, you have a series of angles that are created. If you have lines, notice J and K, I didn't say that they were parallel lines. They don't have to be parallel. It doesn't matter. They could be. It doesn't matter. If I have a line that's crossing over 2 or more others, it's called a transversal, and you have angles that pop up. These angles have relationships with each other. And that's what we're going to look at for the rest of class today. What are their angle relationship names and what do they have to do with each other? Okay, you ready? So there's a couple that we're going to name here. We already know some. We already know things like vertical angles. You already know who the vertical angles are in this picture, right? Can anybody name for me a pair of vertical angles? Carson, go ahead.
Angles 1 and angle 4.
Sure, 1 and 4. So they are the ones, remember that they have to be at the same, they have to share a vertex and they're like staring at, if it was a dinner table, they'd be the ones that you're looking right at, right? They're right across the way from you. Okay. You can't have a pair of vertical angles where one's up here and one's down here. They're different tables. Those would not count. But you could have 2 people that are in the same seat, different location, if you will. So take a look at seat number 1. See how it's in the top left of its little group? Isn't 5 in the top left of its little group? We have a special name for those angles that are in the same spot, but a different location. They're called corresponding. There is a classroom right underneath us that's basically the exact same as this classroom. So there's some kid that's probably sitting in your corresponding seat in the classroom right downstairs. Okay, so our first angle pair relationship are the corresponding angles. I think I'm going to put it over here. Corresponding. Same spot, different location. So let's give our examples. We already said 1 and 5. Does someone think they have another pair? Riley, go ahead. 2 and 6. Let's name them all. What else do we have? Elizabeth. 3 and 7. And so lastly, Riley, go ahead. 4 and 8. Okay, there's corresponding. Now, the next four are all kind of set up the same way. They have two words, and I'm gonna go through how you figure out which word goes where, okay? So, let's see, how should I do this? I think I'll list the four, and then we'll explain how you arrive at one versus another. Yeah, let's do that. Okay, so the next four, I'll put them over here so I have a little bit more space. One of them is going to be alternate interior. Then we'll have alternate exterior. Same side interior. And I bet you could guess the last one. What's the last one gonna be? You got it, same side exterior. Now, what in the world are these? What is going on? This seems so strange. It's not once I explain to you how it's sort of broken up. So the first word refers to where it is in terms of the transversal. Are they on alternate sides of the transversal? So one's on the left, one's on the right, or are they on the same side? So that's the first word. Deals with the transversal. Your second word, either being interior or exterior, that deals with the other two lines that create the angle. So I'm going to say the other two lines. So that means alternate interiors occur on opposite sides of transversal. Between the other two lines. So let me give you a moment to get that down, and then we'll look for some pairs of alternate interiors. Or does anybody think they know? If you want a pair of angles that are on opposite sides of the transversal and in between the other two lines, anybody think that they can come up with the pair? Oh, go ahead. You're in the right ballpark. Those are all the ones that are on the inside. But if I want one pair, so just two of them that are alternate interiors, yes. Sam. You're close. Okay, so let's back up. Who's the transversal? T. So I need one of them to be somewhere on the left and then the other one to be somewhere on the right. Okay, and then I want them both to be in between my other two lines, which in this case are J and K. So the other thing is we don't want to pick two that are right next to each other because those are just supplementary angles. So I'm going to have one up here and one down here. So you could say, Riley, you have a guess? 3 and 6 would work. They are alternate interiors. One's on the left and one's on the right of the transversal, right? Here's my transversal right down the middle. So I've got, they're definitely on alternate sides. And then they are both in between the other two lines, J and K. So 3 and 6 would work. There is one more pair. Julia. 4 and 5 would be my other pair. Yes. Does everybody see that? Okay. So let's write those down before we forget. So our example is, we said 3 and 6. And we also said 4 and 5. So alternate exteriors are almost the same. It's just now they got to be on the outside. Carson, you think you have a pair?
Yeah.
What would
So
you say?
Wouldn't it be 1 and 8?
Yes, 1 and 8 would be a pair of alternate exteriors. They're still on alternate sides of my transversal. One's on the left, one's on the right. And you want them outside of the other two lines, J and K. So 1 and 8 would be good. And there's one more pair. Riley, go ahead. You got it. Okay, so alternate exteriors. Let's say what they do. Opposite sides of transversal on the exterior of other two lines. So our examples for these are, we said 1 and 8. We also said 2 and 7. I bet you have figured out same side interiors, haven't you? Same side just means that they're literally on the same side of that transversal. I'm sorry, I thought my phone was off. I guess it's not. And then interior, I want it in between the other two lines, and exterior, I want it outside the other two lines. So let's see, same side. Same side of transversal. Inside other two lines. Uh-oh. My thing froze. What would be the pair of same side interiors? Sam.
3 and 5.
3 and 5 is correct, or Elizabeth, you could do
4 and 6.
4 and 6. You got it. I'm just gonna write it up. Froze on me. I think we're almost done. So we said 3 and 5. And 4 and 6. And then obviously same side exteriors. These are same side of the transversal outside of the other two lines. Okay, so looking at your picture, sorry, I kind of cut off. Riley, what would you say for same side exterior? 1 and 7 is good. And my other pair, Riley, go ahead. 2 and 8, yes. Okay, now I'm gonna make things a little bit more complicated. I'm gonna give you a trickier diagram. Let's see how you do. don't have to draw this. I wouldn't. Hey, you can if you wanted. Right, and let's label our lines. A, B, C, D, E. Okay. You ready for this? All right. Let's say I wanted to ask you about, oh, I don't know. How about 1 and 11? So first, you need to ask yourself, all right, are these two angles corresponding? Are they in the same spot, but just a different location? No, I agree with you. So now I kind of have to figure out which combination I have here. Oh, you guys already know? Well, hold on. If you don't know, let me walk you through it. You got to figure out who the transversal is. If you were going to take a bus from location 1 to location 11, what bus route are you taking? A, B, C, D, or E? Everybody. E, right? That's the route I would take. Are those two angles on the same side or alternate? Alternate. So we have our first word, it's alternate. Now, the other two lines. What are the other two lines that matter here? Aiden.
A and C.
A and C. Does everybody see that? A and C are the two lines that matter. I don't care about line B. I also don't care about line D. It has nothing to do with these two angles. So if you're looking at those other two lines, are they both on the interior or both on the exterior? Carson.
Exterior.
Exterior. So when we put it all together, these are,
Alternate exterior.
yes. Okay, let's get trickier. What if I wanted to ask you about angles 5 and 12? So think on it for a moment, see if you can get it before I tell you. Oh my gosh. Well, okay, what would you say? They are same side exterior. Now, here's what throws kids off all the time. They're like, but 5 is on the inside of the diagram. I get that, but that's not what interior exterior means. It means of the other two lines that matter. So who's the transversal? It's E. That's my bus that I would take between these two, right? They're both on the same side of it. They're both below it. So same side, and then the other two lines that matter are these two. This is the interior. They're not there. They're both on the outside. Exterior. Good. So it doesn't matter where it is in the diagram. It just matters interior of the lines or exterior of the lines. Okay, let's try another. What if? Oh, let's do. Woo! How about 5 and 17? Think on that one for a moment. Oh, Patrick, go ahead.
Corresponding.
These are corresponding. They're in the same spot, but a different location. Now, I'm going to tell you this right now. Some of you are going to forget about corresponding. You're just always going to go to these 4, and you're going to hit a snag, right? Because you see, okay, B is the transversal. That's the one that connects the two. They're both on the same side. But then when you get to the interior exterior part, now it breaks. Because one's inside and one's outside. You see that? So when it breaks, I want you to remember, oh, could they have been corresponding? And then you're like, oh yeah, I forgot about corresponding. That's what those are, corresponding. Now, will there always be a match? No. You could do something like 5 and 20. Those don't have a match. They're alternate, but I still have one inside and one outside. So when that happens, those just don't have a relationship with each other. So that can happen. How do we feel? Okay-ish? You guys are very good at this, I tell you. Normally this meets with a lot more confusion, but we'll see how tonight's homework goes. So let's see.
So on the diagram you did on, for the notes,
Yes.
4 and 7, the notary.
Correct. All right, so I'm gonna put the homework up over here. I don't know what happened with my computer. Okay. Okay, so there is tonight's assignment. Let me get out of the way here. No, no, just kidding. Okay, let me set this.